So we are back. Hello, Aušrius.
Hello. Hi, everyone.
Dr. Aušrius Juozapavičius is a professor at General Jonas Žemaitis Military Academy of Lithuania, alumnus of KTH Royal Institute of Technology, Stockholm, and Vilnius University. His scientific research ranges from quantum mechanical systems to transportation optimization to management of information systems. His focus over the last 5 years is improving cybersecurity competencies of IT specialists teaching cadets cybersecurity, mostly pen testing, performing research in cybersecurity education. Today's topic is interactive investigation of one cyber attack. Imagine yourself as a system administrator of a small company in the middle of a cyber attack. What would you do? See the link pinned here in comments, which I already mentioned previously. Have you tried to figure out what's happening? So Aušrius will explain all the details of the attack during the presentation. So please enjoy it. And Aušrius, screen is yours.
Okay, hello everyone. So let me share the presentation.
Everything is perfect, visible. Please.
Okay, just open up my spotlight for the mouse. And well, so, okay, this link, you've probably seen it already. And some of you I saw have tried and made, well, your input in what's happening. I can see that Military Academy is quite popular today. I mean, the first presenter, Ludas, from like the director of National Cybersecurity Center, is also one of our alumni. But okay, enough of propaganda. Let's go a bit more technical. So usually I would imagine this to be an interactive analysis, but now it's in parentheses with a question mark because apparently it's quite tricky to be one-on-one with you today. But again, I saw that some of you already tried and solved this attack. By solved, I mean you tried. And if some of you are like good at multitasking, you can just go ahead and run slightly in front of me and try seeing what's happening there. But I will just like go over each step of the attack. It's more or less like a forensics task, seeing what's happening just by looking at available logs and screenshots. And from those who already tried it, I can say that some of you noticed ransomware, some of you noticed data leaks, some of you said it's an insider's attack. So clearly it's a little bit tricky, and that's nice. It means that I can kind of show you something interesting. And if we go to the story directly, this attack is arranged, well, as an educational material. Did it happen in the wild? Well, actually, I don't know. It could have happened because every piece of it is working and tried out. So could be that someone actually made it work just like that. But there are, of course, many steps involved. I'm not sure how realistic it will be in real life, really, but again, we'll see. So the story goes like that, that you are just like one of two IT guys, and you work in a smallish company with 50 persons, and you even have a CISO, or a Chief Information Security Officer, above you. That's, I think, quite unrealistic, because normally small companies like that don't have that many IT guys working, but maybe the company is rich enough to hire all of you. Anyway, at the end of the day, and that's really realistic, people start working when the day is almost over. Some guy called Peter calls you and starts whining that, oh, I cannot access my client's resource management database or website because some link doesn't work in our shared folder. And I mean, normally if someone said that to me, I would understand nothing, and I would say, like, what are you talking about, man? But since you're an IT guy, so of course you work somewhere down in the basement. It could take a lot of steps just to go to Peter's computer. So what do? You of course connect remotely to his machine to like ask him to show what's really happening there, like point me out that link of yours. And sure enough, there is a link in some shared folder, but of course it's not, I mean, it looks slightly interesting, meaning that the icon is a bit off. So if you just look in the command line, what's exactly written in that link, you can see that, all right, there's a URL pointing out to some probably web server. And well, since you're an IT guy, so at least probably you recognize that this 222 is some internal address of yours, and it points correctly to your web server. So that part is fine. The icon file is coming from some network share. 128 actually is your database server, but what on earth? So you could try like going now and looking for problems in this one or that one, but let's start normally, like open up that website and see if it works, because that's the web server. And well, the screen is kind of okay. You try logging in and you have something now. So what I can see is that there's some Python file that's producing an error. Looks a bit, might look like Django, I don't know, and it cannot access, well, the legit client resource management database on that 128 server that I said was the database server. So the IP seems legit, and 5432 port points out to some PostgreSQL service. Right, then let's go to that database server. If you look here, well, I would normally ask you, like, do you see some problems here? But since you cannot say that quickly enough, I'll just have to point out that for you. So this piece of open ports looks slightly suspicious. Well, slightly is an understatement. Normally, databases should be, of course, running on just locally accessible interfaces, but this one is open on all of them. So all these zeros say that this can be accessed even externally. Of course, you need something extra for that, some configuration files that would allow connections from external sites, but at least the port is open. And if you look into database logs, well, lots of stuff here. So let's start just like a little bit slowly. So what's happening in the beginning is that some guy called temp is trying to access database temp from clearly some external IP address, and his password authentication is failing. It's failing several times, but what's actually worrisome here is that this Postgres host-based access configuration file is allowing all access to all databases from all actually IP addresses, and all users can log in if they know the password. So this temp guy doesn't know the password. Several times the login is failing until finally we have a different message here, and this is probably one of the most understated or like misrepresenting error messages, because what it does say in reality is that not just that database temp does not exist. In fact, what it says is that your brute force attack was successful. Congratulations. Meaning that after all these failed logins, suddenly this temp user cannot access the database. So really, that means that the password was okay. It's just that the database does not exist. So what does he do then? Well, I say he, being like sexist here. Maybe it's a she. So she tries then a different database, and well, the next actually two lines are clearly mysterious to me, because as you can see, there's still password authentication failure. But since women's ways are mysterious, let's ignore that for a second. We see that eventually she succeeds connecting to the Postgres database and starts doing some commands, SQL commands, like selecting version of the database server. And well, if you even had some doubts of what's happening before, clearly you should have no more doubts right now, because normally, even if I forget my password after I log in, I don't ask for my database server's version. So clearly something's not good now. And the next sentences like really show that in detail. So the attacker actually selected all database names, chose then CRM database, and dumped eventually all the data. So select everything from clients, from contracts, invoices, users, and blah, blah, blah. And the time of the data leak, I would say, was sometime in the middle of the night. So like at 3 o'clock in the morning. If you look deeper into logs, eventually you'll find that, well, okay, something else is happening. Like 12 hours later. And if you look at the IP address, it's actually different from before. Some blogs base64 encoded are inserted into the database. There were many of them. I'm just showing the last ones. And eventually all of this inserted data is dumped into /tmp tt.so, so shared library. And that library is then used to create a function called sys in the database. And eventually this sys function is called, and I'm sure everyone knows what it is. It's like a reverse bash shell, meaning that the attacker now just has a control of the database shell and server's shell, and the IP address to which the shell goes out is actually the same IP address that was before, the one that did brute forcing attack. So clearly two guys at work here, or at least two computers. And one last thing to note is that this remote shell, reverse shell, actually took 4 million milliseconds. That's like almost 5,000 of seconds. That's 1 hour and a half. And that's actually the end of the attack, 1729. That's when it stopped. If this reverse shell would be still running, you will not even see this line in the logs. But maybe you can then see some suspicious shells open. If you kill one of those, then this line would appear in the database log. But at least for now, we see that it's finished, and it's actually more or less the time to go home, 1729. Well, anyway, let's continue. Oh yeah, this is just a link for those who are interested in how to produce this, what's it called, extended function for PostgreSQL. So it works very nicely with almost every Postgres version. But if you look into what's happening then in the server, eventually you might find something in the TMP folder, because, well, /tmp had one of these shared libraries. So you might look into that deeper, and you see two nice, interesting things here. So one of them is netcat, but I'm not sure why they even need it here. But the one that is really taking my attention is this one, the responder. And it's such a nice tool, but it's a big one. What it does is actually captures, well, Windows NTLM password hashes if someone tries to connect to this computer. But I just jumped slightly ahead of me. What would you notice eventually, according to the story that was formulated in that link, is that you would find that the database is clearly corrupted. So you go to some other, let's call archive or backup server to find the replacements for the database to restore it, and then you see that oops, it's encrypted, and someone asks for some bitcoins. So clearly there's ransomware at work. But now, what really happened here? So a little bit, so some words about the responder. This is not my slide. I just like stole it from this secondhack.in, but I needed just I forgot myself to just take those screenshots when responder was running. But what it does is when someone tries to connect to your machine and you have a responder, it will just grab you this NTLM hash, which you then can actually crack it with John or Hashcat if the password is small enough. So eventually, imagine that someone did that. But how did they? I mean, how did they get someone connecting to this machine? And so how's that ransomware appearing and all that? So we have to go to the beginning to understand what really happened. And actually, the first slide showed everything. So all the other ones were just like misleading in a way. But the very beginning, remember, you connect remotely to Peter's machine and you let him point out the link. So when you browse in Windows to the folder which has this shortcut with an icon file pointing to the database server, Windows will try to download this icon, connecting to this, well, network share. But there is no network share on the database server, except when the responder is running. So if the hacker spins up the responder pretending to be a network share, Windows will magically and automatically, just because you browsed to this folder, connect to that database server trying to access this icon file. And that's when Windows will send your NTLM hash to that database server. So that's the moment when you get really, really, well, what's the word? Hacked. So if you were an administrator and you used administrator's password to log in into Peter's machine and you browsed to this folder with the icon file in the shortcut coming to another server, then actually that was the moment when they stole your hash. Of course, stealing hash is not the end of the world. If your password is like strong, it will take forever to crack it, but apparently this was not the case this time. So RDP was the problem here. And eventually I could say that that was your fatal mistake, but clearly you had a lot of help to get there. So this is a little longish slide, but I still have time to finish. So what were the issues? What were the vulnerabilities implemented in this attack, or, well, used in the attack, but implemented by someone in the system? So there was PostgreSQL, the database running on all interfaces, so open to all the world. There was some setting in Postgres configuration file, lots of zeros instead of local IP address. And of course, you saw that in the logs. There's another line in PGHBA, like Postgres host-based access configuration, which allows everyone to connect from everywhere. So even if the PostgreSQL is running on all interfaces, that's still not enough for you to access it. So you need the second file changed. Why could have that happened? Because, well, as I said, you are two admins, and one of admins was actually on vacations. Could be that he actually fixed these configuration files so that he can access and make some changes, legitimate changes, let's say, from out of work, but in a very bad and well, stupid, I would say, way. But I don't know, maybe it was clever to him. So there's another thing that this temp user that was somehow enabled or created for the database was actually brute forceable. So it had weak credentials, either that or they had been leaked from somewhere else. I don't know, but I mean, it's a long story with the leak, so let's not get into that. But if it were a leak, or if it was known or like in a list of some, let's say, leaked passwords, then using just some cracking software, my favorite would be Medusa, but Hydra works as well. Someone actually accessed the database. Then that's actually the most important thing. If Windows administrator's password was weak, then the responder got that hash, and using John or Hashcat, you could then crack it in a sufficiently, well, short amount of time. And using now your Windows admin's password, you can, of course, access every other machine, including, I mean, if it's a domain, including this database backup file server. One more thing, actually, for the responder to run, you really need root permissions. So the guys, or, well, the attacker, she had to escalate privileges from PostgreSQL user to root on that Linux server. So when I was preparing this attack, this was actually working very nicely. It was called Dirty Pipe Vulnerability, and just took one small command to overwrite root's password. I'll just show you that in a second, but the final one is having shared Windows folders. That's how someone from this database server could eventually create that file, that shortcut, or update that file if it were there for the Peter to use. I mean, not for the Peter to use. Peter said he was using that all the time. So clearly someone then updated that shortcut. And since it was in the shared folder, it might as well be open, but it could have been closed actually and protected with Peter's password. But remember, there was a dump from the database with user accounts. So if Peter was using the same Windows password for the CRM, that could also be a possibility to access that shared folder from outside. Oh, well, anyway, so it becomes slightly too complicated, but let's get back to this dirty pipe vulnerability. Actually, it was such a nice one. I loved it. Like if you look at the password file and you run this, well, proof of concept, let's say, on this password file, this number one means that you can overwrite whatever file, but in this case, starting from position number one. So you leave the R letter standing, but then you replace the next 5 characters with OMAS and the column. So what happens, in fact, that instead of root, you become Romas, and this last column overwrites the X that was before. So when you have no X between the columns, that means that you have no password whatsoever, but you are still root because your ID is 0. And so you can just like SU as Romas without the password, and bingo, you're the root. And then, of course, you can like run the responder and just wait for the administrator to log in into Peter's machine, because that's all it took. Well, eventually, of course, it took them some time to crack your NTLM hash, but that's how the story ends in my case. And the whole scenario was to test what is actually the best time to report the problem. Normally, if the attack is ongoing, every second counts, right? So you could decide whether it's a good enough time to report when you notice the first brute forcing attack, or should you go deeper. In reality, of course, well, at least that's what we hear from statistics. It takes up to 6 months or even longer for companies to notice cyber attacks. But look, let's imagine this hypothetical case that you were in the middle of attack, and in fact you were, because when you logged into Peter's machine and looked at that shortcut, actually that's when the attack really took place, in fact. And so you initiated the attack, and when you are looking at logs, during that time someone is cracking your NTLM hash. So basically every second counts. So when do you really start acting? Do you like go deeper into the reports, or do you call CISO immediately, and so on? That's actually a good question. Therefore, I made this, well, let's say game where you have choices to call CISO, but so far from your answers, I don't see any tendencies whether people want to report early or late, depending on their proficiency. It's unclear. So it's still like mystery for you to solve. So thank you. If you have any questions, I'm sure I have 4, 3, 2, 1 minute to answer.
Okay, thank you for the presentation. This was quite technical one. So thank you for that. And we have, again, a couple of questions from, I suppose, those who tried. So did the company have a SIEM setup in this case?
Clearly not. I mean, since you had to go into the database servers yourself.
And another one, would MFA mitigate the issue, in your opinion?
Multi-factor authentications. I think there's another presentation later on in the day about passwordless logins. I'm sure that's where we're going, everyone. It could be a good thing, sure. So, and like all this, what's it called? The new hype, zero trust. It's always a good thing to have. So yeah, surely this company was, well, normal. It didn't have good security practices in place, lots of things to talk about, but it's an educational material. So what do you know?
And maybe shortly, in your experience, what would be 1 or 2 most effective tools for preventing and responding this kind of cyber attack, or at least first of the list?
Responding, well, just pull the plug. I mean, you're in the company and everything's on premises. It might save you. But really, I mean, I would pull the plug, like internet down, and then you just like switch off everything that you can and start one by one. But just before that, of course, it's a good idea to have good passwords. I mean, really, if you had strong passwords, none of this would happen.
I see. Thank you very much for your answers and for your interactive
one guy is saying that is that a real case? So no, it's not real, but every piece of it is real. So I mean, every small part of the attack is taken from real ones, just like I put them all into one mumbo jumbo, but to be more interesting.
I suppose if there are more questions, maybe the listeners will be able to contact you by your contacts or somehow ask about that, because we are short in time. So thank you very much for the presentation. And now we are preparing for our next presenter.